Hello everyone and welcome back. In the previous lesson, you just learned the basics of NumPy and NumPy arrays. ArcPy offers a function, which this function is actually part of data access. This function is called feature class to NumPy array that in fact converts a feature class to NumPy structured arrays. Structured arrays, they are a different type of NumPy arrays, and sometimes it is easier to work with them, but not always. However, in this class, we keep them as is, and we will be learning how to work with NumPy structured arrays. So let's review one more time. So there is a function of ArcPy data access module. The name is feature class to NumPy array and converts a feature class attribute table to a simple NumPy array. So I put for you guys these two resources. Go read that. However, I will be explaining that in using this very simple scenario. So I imported, of course, I have to, I imported these twice. I'm going to go clean these things up for a second. And of course, I have them twice. Probably I was copy and pasting a lot. Okay, much better now. So let's do this. Here I import first ArcPy OS NumPy as my NP, so I can work with NumPy much faster and easier. And then look at this scenario. I would call ArcPy to look for my land parcels, right? Here is my land parcels. I have a feature layer here. It has all these values, fields, and values. And of course, I have two empty fields in this case as well, right? And I have values of 2004 and 2006. So I have tax values of 2004 and 2006, and I would like to create a NumPy array for them. So I would call ArcPy, then data access of ArcPy, extremely important, then feature class to NumPy array. I pass my feature class. I would ask ArcPy to create a NumPy array for this feature class, and I pass the required fields that I would like to create a NumPy array of it. There are different scenarios that I would get an error if I pass the star. You learn that you can pass a star or asterisk to bring in all the fields. However, NumPy arrays, they are sensitive to null values, integer conversions, and all that. So I specifically pick those fields that I would like to work with. In this case, tax value 2004 and tax value 2006. So what is the structure? ArcPy, data access, feature class to NumPy, the name of my feature class, and a list of those fields that I would like to create an array from. Then I just create a NumPy array. However, remember that these are structured arrays, and I print it. I would ask for the dimension of this structured array and the shape of this structured array. So let's run this one, and as you can see, it shows my structure array. They are a little bit different. However, look at this first item. This first item, let's open my attribute table. Let's change the size a little bit and look at our output. The first item, in fact, is my first row here. I want a tax value of 2004 and 6, so it is 20,000 and 60,000. So this is the first row, is my first feature, and I have items of tax value 2004 and 2006 in it. So I simply can have access to every single feature with tax value 2004 and 2006. And then when so that's my NumPy structured array. However, this time it is telling me that, oh, it's a one dimension. So structured arrays, they are not multi-dimension. However, they give us some very cool functionalities that we will be learning to work with them in this class. So I'm going to go ahead and comment these two lines out. Again, one more time, I would execute my cell, and I see that every item here so this pair would be basically my first row showing tax value 2004 and 2006. Here, I just wanted to show you guys the properties of these type of structured arrays. If I go ahead and I would ask, let's do this. What would be the value in this array with index of 1? You already know that Python is zero-based index, same as arrays. So this whole element here is index number 0. And this element here is index number 1, which would be our second feature, really. So if I go and print this one, it would show that the second element or second feature values of tax 2004 and 2006. So I just learned that I would notice that I can have access to these values based on their indices. What if I go and do this? So when I have double indices, the meaning is this. Let's run it and then learn from what we see here. So in this case, it is looking into so it goes from this way. It is grabbing my my second element or index number 1, and within that it goes and grab the element number 1 in it, because this one is 0, this one is 1. In this case, the first index is showing rows. I'm going to write it here, row, and the second index would be column. Let's change this into this scenario. So row 0, row 1, row 2, and row 3, right? So I'm going to go grab row 3, and in row 3 I have item 0, tax value 2004, and item 1, tax value 2006. So I must get this value. So let's run this one, and it is giving me exactly this value. What is that? Row 3, item 1, based on if this is 0 and if this is 1. Let's go ahead and check that. It is hold on. Let's bring it down so I can see everything. So this is basically item number 0 in a NumPy array. Item number 1, 2, and 3, and this is index 0, this is index 1. So I have this value, I can get access to that value. So as you can see, I can simply convert a whole attribute table to a structured NumPy array, and I can get some information out of that. However, the interesting property of structure arrays are here in this cell. Look here. I can simply ask NumPy array to show me. So here I just got 2 fields. I can ask for one field by passing the name of the field as an index to my NumPy array. So let's look here. I go create a NumPy array with these 2 fields. However, I just want to look at the values in this field. So I pass the name of that field as an index. Look, it is a square bracket, open and close the name of this field to my array. If I run this one, these values, they are all values of my tax value 2004. If I change this to 6, then I simply can have all the tax values for 2006. So I can simply create NumPy arrays and have access directly to each field, really. So that's a very cool property of structured NumPy arrays. Why it is cool? Because what if I would like to have the sum of all values, tax values of 2004? I simply can grab all these values as I did here, right? And then I can ask NumPy, give me the sum. So here I can create a NumPy array, then have access to a field, what field, tax value 2004, and ask for the total sum of all those values. It is telling me that it is this much, 3,476,000. Can I verify that? Yes, I can. I can go here. I can go to statistics, and it is giving me the sum value here, which is exactly same value as I got with my NumPy method. Can I have access to the mean? Yes. What is the average of tax value of 2004? I simply can have access to that, right? What else we can do? So again, remember that we can create NumPy arrays, and we can call, we can have access to a field, those complete values based on the name of the field in a structured NumPy array. So that's make things easy. Look at this example. In this example, I'm bringing zone, tax value 2004, tax value 2006. Let's take a look here. I have zone, tax value 4, and tax value 6. So I simply can create a NumPy array for these 3 fields and save it in my NumPy array. And then I can have access to my, of course, to my tax value 2004. I can change that, and I can get value here to the values of zones, right? So these are fairly simply, I can have access to all the values within a field. However, there is another option. So remember this structure, row and column, right? So here is the column. I can call the column by its name, right? How about rows? So if I go and give this row an index of 0, this means that the very first row here, the very first item, the very first feature what is the tax value of 2004 of it? So if I run that, it's telling me correctly it is to 20,000. However, I still can have some more functionalities here. Look here. I can go and filter my rows. I would filter rows by some expression. For example, go look into zones, and if they are equal to zone D. So look here, I'm going to go and investigate my attribute. I have zone D, right? I have zone D. And here, the meaning of this code is this. Go and probably I did something doesn't look right. Okay, I have to do this. I have to grab the zone like this in this array. So this would be look into zone field, and if the zone field is equal to zone D, then select these rows. So the first item, this whole item, it is giving or selecting or filtering rows. How to filter rows? Go and look into zone field and select those ones that the zone is zone D. And then give me tax value of 2004. So I'm going to go, and all these values, they are tax value of 2004 for zone D only. And then, can I grab the sum of this whole thing? Yes, it is simple. Go np.sum of everything. Wrap everything up, right? Let's try this one. So this is the sum of tax value 2004 for what? For rows that have zone D. The meaning is this. Go select zone D, select by attribute, go select land parcels. If they have zone is equal to zone D, select them, right? There are 20 of them. Then go and grab statistics, right? It is telling me that for 20 selected, what is, one more time, what is the sum for 20 selected? The sum is this value, which is exactly the same value that I calculated over there. So I simply can have access to fields. Not only that, I can filter my rows based on very simple relational and Boolean operators here. Okay, I will see you guys in the next video clip. Bye for now.